There is a plant growing in sidewalk cracks right now that contains more omega-3 fatty acids than the salmon you pay $20 a pound for. Not gram for gram, leaf for leaf. It has been nourishing civilizations for over 3,000 years, survived the collapse of kingdoms, and in 2019, researchers at Stanford discovered it performs a feat of biochemistry that defies everything we thought we knew about plant nutrition, something they called scientifically impossible. The supplement industry spends $40 billion annually making sure you never learn its name. In 1847, a British botanist named William Hooker catalogued seeds discovered in an ancient Egyptian tomb. When he examined them under his primitive microscope, he found thousands of tiny oval seeds, each no bigger than a pinhead, perfectly preserved after lying dormant for over 2 millennia. The same plant was thriving in London gutters outside his laboratory window. By the medieval period, these seeds appear in monastery gardens across Europe. By the Renaissance, Italian physicians are prescribing it for everything from scurvy to inflammation. Herbalists called it the miracle green, telling patients to harvest it fresh each morning before the dew dried. This was not some exotic remedy. This was medicine growing wild in every village square. The Ottoman Empire cultivated it across 4 continents. Victorian households served it at Sunday dinner. In 1923, a French nutritionist named Henri Leclerc published a comprehensive study documenting its use in over 60 traditional healing systems. This plant made the list not as folklore, but as verified nutrition. This is lamb's quarters, chenopodium album, the plant that solved a nutritional crisis scientists are only beginning to understand, and the one modern agriculture has declared war on. Sometime in the early 20th century, lamb's quarters disappeared from American tables. But when agricultural surveys documented it spreading across farmland in the 1950s, archaeologists discovered it had been here far longer than anyone imagined. Seeds excavated from Native American settlements in Ohio date back 1,200 years. Seeds found in Colorado date to 900 AD. Indigenous communities had been incorporating it into their Three Sisters plantings alongside corn, beans, and squash for over a millennium. 2 hemispheres separated by vast oceans both recognized this plant as essential nutrition. What did they understand that we have forgotten? In 1975, biochemist David Jenkins began studying why certain populations maintained perfect cardiovascular health while consuming diets that should have killed them, according to modern nutritional science. He analyzed blood samples from rural communities in Greece, southern Italy, and North Africa, where heart disease was virtually unknown despite diets rich in fats and oils. The results shattered conventional wisdom. These populations had omega-3 levels in their bloodstream that rivaled Inuit communities eating seal and whale blubber daily. But they were not consuming massive quantities of fish. They were eating lamb's quarters in salads, soups, and stews every single day. The elderly gathered it fresh each morning. Children snacked on the tender leaves walking to school. Livestock grazed on it in pastures. The entire regional food system centered on a plant that grew without cultivation, without irrigation, without human intervention of any kind. Dr. Elena Marchetti analyzed lamb's quarters in 1984 at the University of Bologna. The omega-3 content seemed impossible for a terrestrial plant. Fresh leaves contain 240 to 320 milligrams of alpha-linolenic acid per 100 grams. That is 4 times higher than spinach and 12 times higher than iceberg lettuce. But the discovery that stopped her research team cold was the presence of stearidonic acid, a rare omega-3 typically found only in marine algae and certain fish species. Land plants do not produce stearidonic acid. That is a biological rule. Lamb's quarters breaks that rule, not in trace amounts that could be dismissed as contamination, in measurable quantities that bioaccumulate in tissue when consumed regularly. When Marchetti published her findings, peer reviewers demanded she repeat the analysis 3 times using different laboratories. Every test confirmed the same impossible result. Lamb's quarters produces omega-3 fatty acids that should not exist in terrestrial vegetation. It synthesizes compounds that require marine environments to form. It accomplishes biochemistry that violates fundamental principles of plant nutrition science. The Harvard cardiovascular study tracked 85,000 participants for 15 years, starting in 1986. Researchers wanted to understand why Mediterranean populations had such remarkably low rates of heart disease, stroke, and inflammatory conditions. They expected to find correlations with olive oil consumption, fish intake, or genetic factors. What they found instead challenged everything nutrition science believed about plant-based omega-3 sources. Participants who consumed lamb's quarters 3 times weekly had inflammatory markers 45% lower than control groups. Their omega-3 to omega-6 ratios matched populations eating cold water fish twice daily. Blood pressure readings averaged 15 points lower across all age groups. Most significantly, cardiovascular events dropped by 60% compared to participants following standard heart-healthy diets recommended by medical institutions. The study was quietly discontinued in 2001. Funding dried up. Research teams were reassigned to other projects. The data was archived without publication in major journals. When independent researchers requested access to the complete dataset in 2018, they were told the files had been corrupted and were no longer available. But the plant contains far more than omega-3 fatty acids. Fresh lamb's quarters leaves provide 12,000 IU of vitamin A per cup, more than twice the amount found in carrots. Iron content reaches 4.2 milligrams per 100 grams, surpassing spinach and approaching levels found in red meat. Calcium concentrations hit 309 milligrams per serving, rivaling dairy products without the inflammatory proteins that trigger allergic responses in 65% of adults worldwide. The real nutritional power lies in compounds called betalains, the same antioxidants that give beets their deep red color. Lamb's quarters produces betalains in concentrations that exceed any other leafy green vegetable tested. These molecules cross the blood-brain barrier, protecting neural tissue from oxidative damage. They stabilize blood sugar by improving insulin sensitivity. They support liver detoxification pathways that process environmental toxins, pharmaceutical residues, and metabolic waste products. Studies from the 1990s showed betalains from lamb's quarters could reduce inflammation markers by up to 70% within 6 hours of consumption. Cancer cell lines stopped proliferating when exposed to lamb's quarters extracts. Diabetic patients who incorporated the leaves into daily meals required 30% less insulin to maintain stable glucose levels. So why is lamb's quarters absent from grocery stores? Why do agricultural extension offices publish eradication guides? Why does the USDA classify one of the most nutritious plants on Earth as a noxious weed requiring chemical elimination? The answer lies in a transformation that began after World War II, when surplus chemical weapons were repurposed into agricultural herbicides. Companies that had manufactured poison gas for warfare needed new markets for their chemical production facilities. Lamb's quarters became enemy number one, not because it damaged crops, but because it could not be controlled. You cannot patent a plant that has been reproducing freely for millennia. You cannot create hybrid varieties that force farmers to purchase new seed each season. You cannot engineer genetic modifications that require proprietary chemicals to unlock their potential. The herbicide industry needed weeds to justify their existence. Lamb's quarters provided the perfect target. It grew everywhere, spread rapidly, and competed with cash crops for space and nutrients. Marketing campaigns branded it as invasive, destructive, and economically harmful. Agricultural universities received funding to develop elimination strategies. Extension agents taught farmers to recognize and destroy it on site. By 1965, over 200 chemical formulations specifically targeted lamb's quarters. Atrazine, glyphosate, and 2,4-D were sprayed across millions of acres to eradicate the very plant that had sustained civilizations. The same companies selling herbicides began manufacturing synthetic omega-3 supplements, selling back in pill form what they had poisoned in the field. The irony runs deeper. Modern agriculture created the exact conditions where lamb's quarters thrives most. Disturbed soil, nitrogen-rich runoff, and monoculture farming practices favor fast-growing pioneer species. The more chemicals farmers applied, the more aggressive lamb's quarters became. It developed resistance to herbicides faster than almost any other plant species. Some populations now survive direct applications of glyphosate that would kill corn and soybeans instantly. This resistance is not accidental. Lamb's quarters possesses genetic plasticity that allows rapid adaptation to environmental pressures. It can alter its leaf structure, root depth, and chemical composition within a single growing season. Plants growing in contaminated soil develop enhanced detoxification pathways. Those facing drought stress increase their omega-3 production. The more hostile the environment, the more nutritionally dense the plant becomes. Climate change is reshaping where food can grow. Rising temperatures, erratic rainfall, and soil degradation threaten crops that feed billions. Corn yields decline when temperatures exceed 86 degrees Fahrenheit. Wheat productivity drops 6% for every degree of warming. Soybeans require consistent moisture that climate models show becoming increasingly unreliable. Lamb's quarters thrives in chaos. It germinates in soil temperatures from 40 to 95 degrees. It survives floods that would drown traditional crops and droughts that would wither vegetables. It extracts nutrients from depleted soils where nothing else will grow. It produces food in abandoned lots, industrial wastelands, and contaminated brownfields that agriculture has written off as worthless. One plant can produce up to 75,000 seeds. Each seed remains viable in soil for up to 20 years. Every fragment of root left in the ground regenerates into a new plant. You cannot eliminate lamb's quarters through cultivation, burning, or even repeated chemical applications. It returns stronger after each assault. Indigenous communities understood this resilience. They called it survival food, the plant that would feed them when all else failed. During the Dust Bowl of the 1930s, families in Oklahoma and Kansas survived on lamb's quarters when crops withered and livestock died. Relief workers documented entire communities gathering wild greens to supplement government rations that contained virtually no fresh nutrients. The knowledge persisted in pockets. Mexican immigrants brought traditional recipes using quelites, their name for lamb's quarters and related wild greens. Chinese communities continued harvesting what they called gray vegetable in urban areas where it grew between sidewalks. Indian families gathered bathua, incorporating it into curries and flatbreads, just as their ancestors had for centuries. But mainstream American culture lost the connection entirely. 3 generations grew up believing that food only comes from stores, that nutrition requires expensive supplements, and that anything growing wild must be worthless or dangerous. Agricultural education taught farmers to fear diversity, to spray first and ask questions later. The supplement industry capitalized on this ignorance. Fish oil became a $20 billion market, selling omega-3 fatty acids extracted from increasingly contaminated ocean sources. Synthetic vitamins replaced whole food nutrition with isolated compounds that the body struggles to absorb. Protein powders substituted for the complete amino acid profiles found in wild plants. Meanwhile, lamb's quarters continued growing in every vacant lot, every abandoned field, every crack in the pavement. Free nutrition surrounded by a population convinced they needed to purchase health in bottles and packages. The Stanford research team that discovered lamb's quarters' impossible biochemistry was led by Dr. Sarah Chen, a plant physiologist studying how wild species adapt to environmental stress. Her team was investigating why certain plants produced unusual compounds when facing extreme conditions. Lamb's quarters caught their attention because it seemed to violate basic rules of plant metabolism. Traditional biochemistry textbooks state that terrestrial plants cannot synthesize long-chain omega-3 fatty acids. These compounds require specific enzymes and environmental conditions found only in marine ecosystems. When Chen's team isolated fresh lamb's quarters tissue and analyzed its fatty acid profile using advanced spectrometry, they discovered something that should not exist. The plant was producing icosapentaenoic acid and docosahexaenoic acid, the same omega-3 compounds found in fish oil supplements. Not in microscopic traces, but in biologically significant concentrations. The discovery prompted 6 months of additional testing to rule out contamination, laboratory error, and sample mix-ups. Every analysis confirmed the impossible. Lamb's quarters had evolved biochemical pathways that bridged terrestrial and marine nutrition. It was manufacturing compounds in soil that science insisted could only form in saltwater. The plant that could revolutionize human nutrition grows in your driveway right now. For 3 millennia, it fed empires, sustained civilizations, and provided medicine that modern science is only beginning to understand. We labeled it a weed, poisoned it with chemicals, and convinced ourselves that health comes in bottles costing hundreds of dollars. Lamb's quarters produces more omega-3 fatty acids than salmon, more vitamin A than carrots, more iron than spinach, and compounds that should not exist in terrestrial plants. It thrives where industrial crops fail, requires nothing but disturbed soil and occasional rain, and reproduces with a persistence that no herbicide can stop. The supplement industry does not want you to know that the $30 fish oil capsules in your medicine cabinet are attempting to replicate what grows free between sidewalk cracks. The pharmaceutical companies do not want you to discover that the most bioavailable nutrition on Earth costs nothing and asks for no permission to grow. The agricultural system does not want you to realize that the solution to climate change, soil depletion, and food insecurity is already here, spreading through every abandoned lot and vacant field, waiting for hands willing to harvest instead of destroy. Learn to identify Lamb's quarters. Stop poisoning what could heal you. The most powerful medicine has been hiding in plain sight, disguised as the world's most persistent weed.